on to the next examples. Now, common logarithms. Now, this is, will just take a little getting used to, but it's not too bad. If there's no value of a in the expression log a to the x, the base is understood to be 10. This reminds me of right when we write x. We don't write a 1 in front. We don't write 1x because we understand it's a 1 out front. Or if we have exponents too. If we have a 5 to the exponent 1, we usually don't write the 1. We just write 5. And in the case of logs, it's 10. And why 10? Well, 10 is the base we count in. Think about counting numbers for a second. I can't resist going over to here for a second. Let's talk about how we count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what happens after 9? We go to a new column. I don't know if you ever thought about this before. You just do it kind of automatically, but it's base 10. After 9, we go over here and go one of these and none of these. So the base we're using is 10. 10 is the key to how we're counting this stuff. Now, going back to here. There. So base 10 is chosen because it's the base we use most often. So when you see log of x and there's no base there, now look at your calculator again. Some of you have a calculator that have a log button, but not a log base something button. And the log button that you have is a log base 10 button. All right? So anytime you're looking at a homework or something on a test and you go, oh, what base is it? It's a 10. So feel free to write the 10 in there if you need it. Okay? And logarithms of base 10 are called common logarithms. It's the most common base we use, so it's called common logs. So here's an example. Evaluate each of the following. Log of 100. At first it seems like that would be a bit of a challenge because it doesn't show the base, but we understand that that's base 10. Okay, so what power do you put on 10 to get 100? Exponent you put on 10 to get 100. If you put 1 on there, you get 10 to the 1, you'll get 10. How about 10 to the power 2? Punch in your calculator if you have to. Maybe that one's one you can do in your head. 10 to the power 2 is 100. So the power I put, the exponent, and I'll look here. The exponent you put on 10, because it's understood to be 10 if there's nothing there, is to get 100 is 2. Let's try another one. Exponent you put on 10 to get 1 over 1,000, and hopefully by now you're starting to go, okay, if it's a fraction, we're talking about a negative number, and then I can, once I've decided that, I don't have to worry anymore. I can just think about the 1,000. What exponent do I put on 10 to get 1,000? 10 to the power 2 is 100. 10 to the power 3 is 1,000. So we're talking about a 3, but negative because it's in the denominator. So negative 3. Log of 57. Well, okay, one thing we could do, and this is a fun game to play for any of you who need a good party game. If you want to find out what exponent you put on 10 to get 57, you just get your calculator out here, and here I go. 10 to the exponent of, well, I know it's smaller than 2. 2 would be 100, so I'm going to go with 1.5. 10 to the exponent of 1.5. Let's see what I get. 31, too small. So let me go back, and I'm going to change this to 10 to the power of 1.6. Ooh, still too small. I'm going to go back. Backspace. Here we go. 10 to the power of 1.7. 50. Well, we're getting closer. Let me go back. How about 10 to the power of 1.8? 63, too big. So it was 1.7 was good. So let me go, I'm going to try and get it closer. 10 to the power of, bigger than 1.7, but not as big as 1.8. 1.75. So 56. Oh, I'm getting really close. That's pretty good, 1.75. I think, so you could play around and get this as accurate as you want just by playing back and forth. Now, obviously, mathematicians aren't going to do that, and that's what this log button is for. You've got a log button right there, and you actually just type in log 57 and you get the answer. Now, instead of doing your homework tonight, what you could do is just play around with that and see if you can get this answer. All right, or find some other logs that you want to, some other numbers you want to find logs up to all the decimal places. It is not a bad exercise to get to understand what it is you're trying to come up with here, but the calculator will pump it out as long as it's log base 10. So you pump in your calculator. Use your log button on your calculator. It calculates logarithms with base 10. So you punch that in, and it comes out to about 1.76. Of course, on any test or anything like that, we'll tell you exactly how many decimal places we want in any particular situation.